Alright, let's talk about antibiotic resistance. Most people have probably been prescribed an antibiotic to treat some of the infections that exist. If you have, you know that you are supposed to take the full dose even if you are feeling better. This is because of antibiotic resistance. If not all the bacteria are killed by the antibiotic, the surviving bacteria will have the ability to fight off the drug that's supposed to kill them. This makes them and all of their future generations resistant to the antibiotic. This is how superbugs are created. Antibiotic resistance is dangerous because if a bacteria becomes resistant to all antibiotics, it becomes almost impossible to treat. Beta lactam antibiotic has attached to the penicillin binding proteins. The transpeptidation reaction is inhibited, peptidoglycan is blocked, and the cell dies. E. coli is a bacteria that is pretty much everywhere. It normally lives in the intestines of humans and animals. Most strains are harmless, but there are some that cause severe intestinal issues. Now let's talk about ampicillin. Ampicillin is a medication used to treat bacterial infections. It was made to help stop drug resistance. It is part of the penicillin family and functions as an antibiotic. It is also known as a broad spectrum penicillin. E. coli has become very resistant to most antibiotics over time, and it is called multi-drug resistant. Many journals have found that after multiple exposures to ampicillin, E. coli can develop resistance to the drug. It has generally only increased its resistance rate over time, but scientists and doctors are working to bring this number down. So how does AMP work? AMPs are typically small and charged molecules that can be produced in a variety of structures. Now, now that they are diverse, most AMPs work by interacting with the bacterial cell surface, which is followed by disruption of cellular integrity. How does AMP resistance work? The AMP resistance gene produces beta lactamase to degrade AMP and therefore prevent cell death. So, how many colonies would be grown for LB cultures on the LB plate versus LB8 with AMP plate, and why? So we think that the LB cultures will grow more colonies on the LB with AMP plate because since E. coli has been fighting off AMP for a while, and like it's an antibiotic drug, obviously. So it got used to it to the point that it will go ahead and grow more colonies. Now, as for the LB with AMP cultures, we think that it will grow on more colonies on the LB with AMP plate than the LB plate, because, like I said, they are fighting more antibiotics, which therefore they will spread out more and faster. For cultures grown on LB plates, we also think that it will grow more with the with LB AMP culture plate, because like I said again, there is more resistance to the AMP, which therefore will fight it. So knowing what we know about antibiotic resistance, we believe that the LB with AMP will have more colonies than the plate without. This is because after a few weeks of exposure to the ampicillin, the bacteria will have time to form a resistance and it will come back stronger. This will be an example of a superbug. It is what we want to try to avoid in doctors treat bacterial infections.